Dr. Dedi Meiri is an assistant professor at the Faculty of Biology at the Technion Israel Institute of Technology and a member of the Technion Integrated Cancer Center. Dr. Mike Dixon is a professor in the School of Environmental Sciences and director of the Controlled Environment Systems Research Facility at the University of Guelph. Please put your hands together for today's keynote.
Hi everyone. So we tried to do something new today, that we will speak together. I will give the first part of the talk and Mike will go ahead from there. I will try to build my talk in a way that will be his introduction. I know Mike for I think 2 years and we're working together. So let me see how this works. So as I've been presented, my name is Dedi Meiri. I'm a professor or assistant professor at the Technion, which is the Technology Institute of Israel. And I have a lab that in her title, it's a lab for cancer research. Around 4 years ago, I started to work on the anti-cancer properties of cannabis. And quite fast, I find out that cannabis is working on many pathways and affecting many diseases, not just cancer. And today my lab is a big lab that's working around the neurobiology. We have a mice model, an animal model, and cell model, and clinical trials in epilepsy, Alzheimer's, sleep disorders, multiple sclerosis, autoimmune disease, and of course cancer. So how come that one plant is affecting so many diseases? When I started 4 years ago, I didn't believe it. It sounds to me like a bad joke, and I thought that this is not real. But to understand why this plant is working on so many illnesses, we need to understand how it's working. The cannabis is a unique plant that produces molecule called cannabinoids. I'm sure that everybody here heard about them. And these cannabinoids affect our body through a mechanism, through a system called the endocannabinoid system. And the endocannabinoid system is homeostatic system. It's a regulation system that sit on top of other systems and regulate them, bring them back to balance. In 80%, I would say, from the effect of the endocannabinoid system is bring back to our other systems in balance. When we have inflammation and we have hyperactivity of the immune system, the cannabis is balancing it down. When we're feeling pain, when we're touching something very hot and our hand moves, now to bring back the sensitivity of the end of the neurons, of the tip in our fingers is buying the endocannabinoid system. So it's a regulation system, and that's the reason that it's affecting so many other systems. So our body built from cells. Cells is the basic unit. You see here one cell. This is one cell. Cell is a basic unit that all the living creatures build from. I think, except viruses, every creature has cells, and this is the basic unit also in our body. But if you're taking one cell from our body, it can live alone. These are cells that are moving on the plate. 2 more cells, it doesn't matter, but one cell from our body can be grown and can be a self-unit. But in our body, these cells need to communicate with each other because they are living in tissue. They have a lot of friends around them. When I'm moving my hand like that, a cell from my brain, a neuron, sending a signal to a cell, to muscle cells in my arm that need to contract. And these cells need to contract with a full communication with the other cells in order to make it very fluently. And the way cells communicate, they're sending messages. So here are few cells in the plate, and these two need to communicate. And how they communicate? They're sending messages. And the other cells need to read this message. We call it the hormones, we call it cytokines in the immune system, and we call it cannabinoids in the endocannabinoid system. So the cannabinoids are the messages that are being sent from one cell to the other cells. And on the other cells, we have the receptors that need to catch these signals and read it. So we have the cannabinoids. In our body, we will call it the endocannabinoids. And we have the receptors on the other cells to catch them and read them. Usually people in the endocannabinoid system talking about two receptors, CB1 and CB2. But the truth is it's much more complicated. There are GPR55 and GPR18, GPR3, GPR12, GPRPV1. In my lab, I'm working on 30 different receptors. And if I'm working on 30, probably there are 50. And also the endocannabinoid. These are the ones that read, but the endocannabinoid, the messages. Usually we're talking about anandamide and 2UG. But in my lab, I can identify over than 140 different endocannabinoids from a single blood test. So we are talking about a very, very, very complicated system with many receptors and many ligands, many messages, which we call them endocannabinoids. The plant, the cannabis, is one of the only plants that we know that can create also these compounds, also these messages. And affecting our cells in our body by binding the receptors. He's sending the messages. It's actually doing a bypass. So the cannabis is creating the compound phytocannabinoids, which are very similar to the endocannabinoids. But again, the cannabis is not creating one compound like that. It's creating many compounds like that. There are at least 10 families of phytocannabinoids, and in my lab I can identify over than 140 phytocannabinoids from the plants. But if to make it more complicated, there are other compounds in the plant. There are terpenoids and flavonoids that also can activate our receptors. So in altogether, we're talking about more than 500 compounds in one plant that can affect our receptors. So actually what the cannabis is doing a bypass. When we're moving near a barbecue and smelling the barbecue, small molecules from the burned meat is entering our nose, going to our olfactory system, signaling to our neurons that create a specific endocannabinoid that will bind a specific receptors on a cell nearby to send a different message to our pancreas to start to create insulin. And this is a feedback loop that will increase our appetite. So we know that we are walking near a barbecue and smelling it increase our appetite. The cannabis is just doing a bypass. Instead of sending a message with a very specific message, it's binding directly the receptors and increase our appetite. We know it, we call it munchies, right? But you need to understand that when we're talking about the endocannabinoid system, it's very, very, very specific. A cell in our brain will create a specific endocannabinoid that will bind a receptor nearby him, somewhere here. But we have these receptors all over our body, in our immune system, in our heart, in our liver. Different receptors, different combination of these receptors. And when we're smoking cannabis, or inhaling cannabis, or taking pills of cannabis, we're entering not one molecule specific in this neuron, we're entering into our body tons of compounds that will bind a lot of different receptors, and this will create a complicated action. We call it an entourage effect, just because we don't understand it. But this is what we say. This compound, we call it ligand in biology. These are the messages. They need to bind the receptors. But we call it the lock and the key principle. It's not that every message can bind at every receptors. A receptor will have a unique structure that will bind a unique message, a unique cannabinoid. And it doesn't matter that we're coming with a huge amount of keys. If there is not the right key that will enter the right lock, it won't open it. So it's not that we need a lot of compound in order to open one key, to have one message. This is not the entourage effect. The entourage effect is because we have many receptors that being affected on many different compounds that we're taking together. And we're getting a complicated action. THC will bind CB1 and also GPR19 and will start at different pathways in the cell. And CBG will bind GPR55 and start another pathway in the cell. and CB1 binds CB2 and started another action in the cell. But it's not a synergy. It's a complicated action because CBL can block CB1 and it can compete with THC. So we're getting a very complicated action on our cells when we're inhaling cannabis or smoking cannabis. And that's what we call the entourage effect. It's not one compound, one receptor. It's a lot of compounds and a lot of receptors and make a complicated action. So if you want to see the real picture, it's something like that, just with 5 receptors. So let's go back to my lab. Mike, did you look on the clock? I didn't. You're good. I'm good. For how long?
10.
10, okay. When the guy that coming after you is sitting behind you. Okay. So let's go back to my lab. As I told you, 4 years ago, we started to ask what are the anti-cancer properties of cannabis. But cannabis is a giving name to many, many different species. Yeah. So what we said, okay, let's take few types of cancer, let's take few types of cannabis, let's grow the cancer cells, and try to see how the cannabis affect them. Still 4 years ago, we knew nothing. So what we did, we are growing cells in a plate, tumor cells. In this plate, there will be between 3 million to 10 million cells, depending on the types of the cancer. And then we making an extract of the cannabis and put them on the cells. So what you see here, these are colon cancer, and every dot here, it's a cell. It's a lower magnification. So you see every cell like a dot. In this picture, there is, I would say, around 2,000 cells. Okay? And now we're taking the cannabis, we're making an extract, and we're putting them on the cells. And we saw that extract number 1 kill all the cells. We put extract number 2 and it's also kill all the cells. But extract number 3 didn't affect the cells at all. So we see that there was a specificity between the types of the cannabis and its ability to affect these cells. We took breast cancer cells and we saw a very similar phenomenon. But when we took a prostate cancer cells, extract number 1 that killed the breast cancer, the colon cancer, didn't affect the prostate. When we used extract number 2, we saw the same thing. But extract number 3 that didn't affect the colon and didn't affect the breast, now killing the prostate cancer. When we used normal colon cells, the cannabis didn't affect them in that amount. So what we saw a specificity between the types of the cancer and the types of the cannabis that can affect them. But what was unique here is the amount of the cannabis that we need to add to these cells. Every cell every materials in the world will have what we call IC50. What is the amount that you need to put on these cells in order to kill them? If you take glucose, salt, rosemary, you will extract rosemary, you put on the cells, it will kill them. But there is something that we call a therapeutic window. So if you're taking rosemary, and I did it on these colon cells, and you extract the active compounds of rosemary and you put on these cells, you need something like 60 milligrams per ml in order to kill these cells. When you're doing this calculation for a person, you need to eat something like 50 kilograms a day of rosemary. This is not a therapeutic window. In cannabis, it's 1 microgram, 60,000 times less than rosemary. So on average, a person needs to take, in this calculation, 1 gram. I have few friends that are using much more than 1 gram a day for years and nothing happened to them. The average patient in Israel getting 34.5 grams a month. So I already know that I have something that's killing these cells, but it's not toxic in that amount. If I need to use chemotherapy like Taxol or Vincristine, the most severe chemotherapy that I need, it's the same amount that I need to use cannabis. So I have now a material that I know that it's not toxic, but I affect on these cells as good as chemotherapy. This is crazy. I was so excited. But now, what is the difference between extract number 2 and extract number 3? It's the cannabinoids, what I have there. I send them to a laboratory to read, and they read 5 cannabinoids, THC, THCA, CBD, CBDA, and I saw that extract number 2 and extract number 3 looks the same. So it's not just the THC and CBD. I understood that it's something about, and I knew that there are hundreds of compounds there. So in order to solve that, first we want to prove for ourselves that it's not just the THC and CBD. So what we took 20 different cultivars, and we took now, what was it? It was melanoma cancer, it doesn't matter. And what I'm showing here, these results. Every color here, it's a different chemovar, different types of cannabis. And we see here the percentage of cells that are dying. And let's take 4 microgram paravel, and you see there are a bunch of extracts that didn't affect, and a bunch of extracts was very useful to kill these cells. It's similar to what I showed you. But now I'm taking all these cannabis, all these cultivars of cannabis, and I've aligned them by the percentage of THC and CBD, and I see that there is no correlation between the amount of THC and CBD and my ability to kill these cells. Now I'm doing another trick. I'm taking one of these, Michael, that's killing 70% of these cells after 24 hours. And I'm extracting just the THC and the CBD, purified THC and CBD, and I put them on the cells, and even if I put 20 times more than I have here, it's not affecting the cells. So what I learned that it's more complicated, the THC, CBD, CBG. The other compounds are very important also. So first of all, we developed a method to analyze all these compounds, to analyze all the 140 cannabinoids. So we're using LCMSMS and GCMSMS and HPLC, HPLC, all these ugly names in order to analyze these chemovars. So if I'm showing this is a for publication that we published 2 months ago. These are the 20 extracts, the 20 chemovars that we choose, and these are the cannabinoids. And what I'm showing here, we call it heat map. So when these cannabinoids, phytocannabinoids, it's dark, the meaning is that it's highly expressed in this strain. And when it's white, the meaning that it's not expressing this strain. What I want to show you is how much these chemovars, how much these strains are different from each other. So if a patient taking these high CBD strains or these high CBD strains is actually taking a totally different medicine. And I want to show you under the cancer research that we're doing, even though it's true for the epilepsy and the Alzheimer, for everything else that we're doing, I want to show you how we look on that. So first of all, you need to understand that cancer, it's a given name to hundreds of different diseases. We put them in a box. We call it the 6 hallmarks. We said every time that a cell has 1, 2, 3, 4, 5, 6, we call it cancer. So colon cancer, it's a given name to few different diseases. So first of all, what I want to show you, that if I'm taking a colon cancer, and again, every color, it's a different chemovar, a different strain of cannabis, and how much it's high, meaning that it's killing more cells. So you see, in this type of colon cancer, we find 4 different strains that was very useful to kill these cells. But on this type of cancer, colon cancer, none of the 650 different strains in my lab affect these cells. So even in the cancer, there is difference. So how we look on that, how we are looking in the lab, we're looking very, very specific, what we call personal medicine. We look on specific cancer with a specific mutation and specific types of cells, and then we're looking which cannabis is affecting them. So what I'm showing you here, it's 4 different cells with the same type of mutation, the same types of the cell. The blue one is without mutation, and I won't go into the details. I just said that the color is made, the meaning that the cancer is more severe. So the yellow one is the most severe one, but it's the same types of cancer with the same mutation. And now what I'm seeing here in the graph is how many cells survive. So if the bar is low, the meaning that more cells die. So what we're doing, we started to screen, and you see this type of cannabis didn't affect the cells at all, and this didn't affect. Until we reach one of them, that it affects according to the mutation in these cells. As the mutation, as the cancer is more aggressive, the cannabis is killing it better. And the normal one is not affecting them. When we're finding something like that, we're going deeper and deeper. We started to ask the biology, what is the changing in these cells? Why it's killing when we have this mutation? We prove for ourselves that what we see is true. We're doing a rescue. We're going to a mice model. We're putting these cells in the mice. We're creating the tumors in the mice, and we're treating them with cannabis. So, sorry for the ugly picture, but these are tumors for a mice that have not been treated, and this is 3 weeks treatment with this cannabis. And you see that it's smaller the tumors. It's decreased the size of them. And when we're finding everything and we prove for ourselves that it's working, now the big question, what are the compounds in the cannabis that are doing this effect? My slogan to my students, I want the minimum compound that doing maximum effect. So what we're doing, we say, okay, we have here 40 cannabinoids, 30 terpenes, 20 flavonoids. I'm going to the equipment, then doesn't matter how we're doing it, and I'm telling them, separate them to 4 different groups. The guys from Tirmo, he's laughing, yes, it's your equipment. So I'm separating into 4 groups. I said, the first 25 compounds put in the first tube, the second in the other tube. I'm doing fractionations. I'm separating into groups. And then I'm going back to the cells, and again what we see here, as if it's low, the meaning that it's kill more cells. The red one is the whole extract. And every different color, it's a fraction, 4 fractions, 25, 25, 25. And you see that just one fraction is killing the cells as good as the whole extract. So I eliminate 75% of the compound that I don't need. And we go on, we're taking this one that works and we keep cut it. Now I'm telling the equipment, cut it to 5 compounds, 5 compounds, 5 compounds. And we're doing this combination until we reach to the minimum compound that's doing that effect. In this type of cancer, what I showed you, we reach in the end to just 3 compounds. Purified compounds, 3 purified compounds, they're doing the effect as the whole extract. So it's not one. It's still the entourage. But do we need everything? No. We need just 3. And we understand one of them binding TRPV1 receptor, activate calcium signaling. The other one is binding CB1 and activating the MAP kinase. I know the signals. But I need the 3 of them. If I'm taking one of them out, it's not working anymore. But more than that, one of these compounds, one of these cannabinoids, doesn't even have a name, 3318B. So if I wouldn't look so deep, if I would look just on THC and CBD, I wouldn't know that it's there. One strain would help on this cancer and the other not. But now I will ask you a different question. How do I know that every time that I'm growing this strain, I'm getting these cannabinoids if we never looked on them? I'm speaking with the growers, Canopy, with Aurora, with MedRelief, with Kronos. Oh, we are standardizing the way our crops are always the same. But you're checking 5 cannabinoids. How do you know that 3318B is still expressed? We don't know. So I can show these results in many other aspects in epilepsy, and I think I ran out of time, so I won't go to the other examples, but the message is that we need to look deeper, and we need to standardize it. And one of the projects in my lab is database. Israel is a small place. We have just 8 growers. And every grower presents to the patient around 10 different strains. So altogether I have 94 different strains that the patient can get. And we're allowed to give the patient just flowers or oil. So altogether I have something like 130 products. So what we're doing in this project, we're following up on every cannabis that the patient can get in the last 2.5 years. Every cannabis that the patient can get, every batch, every time that they grow, pick a new batch or create a new oil, we're getting samples to the lab and we analyze all the cannabinoids, terpene, flavonoids inside. So at least I know what every patient is getting. It's not accurate as I want to. I don't know how many puffs the patients get, but at least I know in Scooby-Doo strain or White Widow in January for Candor what goes inside. On the other hand, we are doing a follow-up on the patient. We follow up the patient every month. We have 5,500 patients in this questionnaire with elevation of 100 patients every week. That we have follow-up. We know what is the cannabis they are getting from bottom to top, and then we know how it's affect them, and we know, and we want to match this database together to say these 50 strains increase appetite in 80% of the patient. What we have in these strains, what are the common compounds, these strains that are not existing in the strains that not elevate appetite, and this to take to animal model and clinical trials. I want to give you one result that started from autistic kids, a clinical trial that we prepared. And we knew from this database what helped these kids, which strain is the best for these kids. And we want to start a clinical trial to prove it. This clinical trial is running already for 1.5 years. This is an old result. But we want to show and to prove that it's really reducing their aggressiveness, improving their ability to communicate, reduce anxiety, and all these parameters. And we knew what the strain. So we approach one of the growers that grow these strains, and we want him to grow a big batch of this to create an hold to this clinical trial. So this grower, in order to grow these strains, had to use 4 different greenhouses that he had. And analyzing, this is all the strain, doesn't matter at all, and analyzing these 4 strains, this is the result that we got. Again, it's the same genetic, the same strain, just growing in 4 different greenhouses. And you can look how much it's different, just changing the environment. We thought in that days that THCV is very important in this affecting of reducing aggressiveness. And you can see that one cultivar one grow, it's the same cultivar, don't have THCV at all, it just disappeared. So just changing the environment can change it. Guys, I'm a son of agriculture. I grew plants many years, and also I did my PhD is on genetic and plant biology. And it's not surprising, guys. When we picked, as a child, when we picked strawberries in the morning or afternoon, they had a different taste. Afternoon they are more sweet. And today I understand they are doing photosynthesis all day, creating sugars, and at night they're breaking the sugars. But the plant changes secondary metabolites all the day long. There is something we call touch genes. If you touch the plant more, the plant thinks that you is become somebody coming to harvesting, and it will create a defense mechanism. It's called touch genes. These are secondary metabolites like cannabinoid terpenes. So even touching the plant more than other plants can change them. How we can grow the plant in a way that we will make it a medicine. This is what Mike Dixon is expert in, and he will take it from here. I just want to say thanks to my group, and mainly to a few people. Shirley Berman, that did all the cannabinoids and endocannabinoids analyzing with the mass spec. Dr. Yigaluria, with the head of the neuroimmune therapy in my lab. Dr. Liran Baram, that's doing all the cancer. And Dr. Gil Levitus is the head of the neuro department in my lab. Thank you very much.